is equal to 0. Okay? So this is the first condition. And then in the second condition, right, we have stress X is positive, okay, means tensile stress Y is negative. And then we have a third condition or we have a stress Z is equal to 0. Okay. Now, when we look at the element, so the element, this element over here is oriented okay, at its principal plane, okay, is oriented at its principal plane, i.e., shear stress is all equal to what? 0. You don't see any shear for this element. Okay. Then in condition number 3, condition number 3 is where you have stress X is greater than stress Y, which is greater than stress Z, and all are positive. Okay. So we are going to look at the stress state of these three conditions. Okay. So we are going to do condition number 1. Okay. Where we have stress X is greater than stress Y, and both are positive. And then we have stress Z is equal to 0. Okay. So the element is still, we are still referring to the same element. Okay, so our be the element, and we paste down here. Okay. So now we are going to sketch our first 3D Mohr circle. Okay, we'll sketch our first 3D Mohr circle. So again, still the same. We have our okay. So this is our normal stress, and then we have our shear stress. Right? Element rotate clockwise, anti-clockwise, and we are given stress X and stress Y are both positive. So this is our the line. Okay. So this is our stress Y line, and then we have our stress X line, and then we have our stress Z line. Okay. So we know the shears are equal to 0. Okay. So like it's the same like what we have learned before. This is our point X. Okay, a Mohr circle. Point Y, and this is our point Z. So over here, this is our point X, and over here, this is our point Y. Okay. So now we can draw one of the circle. Okay. And this circle over here, it belongs to the what? X, Y plane. And our XY plane, as you can see, is our in plane. Okay, it's our in plane. And then we can construct. Okay, so this is just doing simple 2D Mohr circle. Okay, now if we just do 2D Mohr circle, and when we ignore 3D Mohr circle, I'm going to show you the consequences. Okay, so the next two circles I'm going to draw is based on 3D Mohr circle analysis. Okay, watch. We know that stress Z is equal to 0. Okay, so this is our Z point. Then we are going to draw another circle. Okay, so this is our next circle. So now this circle, because it touches Y and Z, this circle belongs to our YZ plane. And this is our out of plane. Okay. Okay. So something I want you all to see now, okay, is over here. This is our tau max for the XY plane. Okay. And then the next line I'm going to draw, right? This is our tau max. Okay, this is our tau max for our YZ plane. Then we still have another circle to draw. Okay, and then the last circle that we're going to construct okay, the last circle we're going to construct is this circle over here. Yeah, we shape it slightly lower. Okay, and this circle, because it touches the bigger circle, it touches point X and point Z. This circle itself belongs to the XZ plane. And when you see XZ plane, this is our out of what? Plane. And what you realize now is this circle, right? This circle over here is your tau max, right? Exact plane. Okay. So what you can see now, right, is the bigger circle is the most important one. Okay, in any of your analysis, the bigger circle will affect will see whether will your structure fail or not the smaller circle. But in order to draw the bigger circle, you have the smaller circle. Okay, so what you can see, okay, so now I'm going to bring your case back. If we just do 2D Mohr circle, right, you only draw the XY plane. Okay, on 2D Mohr circle, you only draw the in-plane stress state. When you go into 3D Mohr circle, right, you realize that the tau max in the what? Exact plane, the out of plane is the biggest circle. So without the biggest without the exact plane circle, right? You will assume that the in plane is the maximum tau max, which is not the case, as you can see over here, right? So from here, we can immediately write down or state here. Okay, we can write over here is tau max is in fact tau max for the exact plane. Okay, and this is equal, right? This is equal to stress X right? This is equal to stress X plus by stress Z divided by 2. Okay. So we know that stress Z is equal to 0, right? We know that, note, that stress Z is equal to 0. Tau max will be equal to stress X divided by 2. Okay. Or, okay, what we can write down is stress max divided by 2. Okay. Because at this point over here, okay, I'm going to change color. At this point over here, this is our stress max. At this point over here, this is our stress mean. Okay. And what we realize down here is the maximum shear stress is out of plane. And to get this out of plane, only possible with 3D Mohr circle. That's why we have to analyze 3D every time. Okay. If that's the case, have a great weekend. I'll see you all next week for a 3 hours lecture. And then next Friday is your term test 1 in person. Okay. Bye. Have a great weekend.